Hey, hello, RC4ever here. This may not be my most glamorous video, but I have been asked many times already and for a long time to make a video of how I have my F-22 set up, and I never come to find the time to do it, so I thought, okay, just take the camera and go down to the garage. I mean, I'm still in pajama, but anyway, let's try and get this out of the way because you guys have been asking for it for a long time and I'm way overdue for this. So let's start. First and foremost, I will go over the aircraft. So, well, you can see already that this jet has taken quite a beating. It had a couple of accidents, but I mean, it doesn't show in flight, so it's not such a big deal, and it still flies like a dream despite the problems. You also can see here the gold tint that I made to the canopy. This I did with airbrush, and actually, as a matter of fact, if you give me 1 second, I may even find the reference for what I used, which must have been, yeah, this is the one. This is what I used. This is from AK Interactive Metallic Modeling Colors, and this is brass. AK 11194 is the reference, if you want to copy that. Be careful if you do this, because metallic paints have a way of interfering with radio signals, and it just so happens that for many of us the antennas of this airplane are just beneath the canopy. So if you're running telemetry, you will notice that by doing this you are making your signal reception worse, so have that in mind and be careful. And now let's open this and see how does this look inside. So there we go. First and foremost, you see that there's here a wire connecting my canopy to the battery compartment, and this is because I installed an LED, which hard for you to see now since, well, maybe it's there right on the head-up display, but with the gold tint it's a little difficult to see. So, and this just plugs straight into the receiver, and here are there are a couple of resistors to make it work so that the LED will not burn. And I just connect this, I plug this straight into the smart port of the receivers, which is very convenient. Then the antennas, as you see, are at 90 degrees to one another. This one is in the vertical plane. I don't see if you can see this. Let me zoom in. Okay, there you go. There's one and there's the other. So this is how I set my antennas. And then you can also see that my battery compartment is pretty clean. I did quite an exercise of cable management, and of course I removed the blue control box to be able to shift the batteries aft, and everything that comes out of the receiver goes straight underneath the battery compartment wooden tray. And I'm not going to open this now, but you can find here an external battery elimination circuit, so BEC, through which I plug all the, or rather, I use this to power all the electronics of the aircraft with the exception of the ducted fan itself, and this is the sort of battery that I use for that, which is 2 cells, 600 milliamps hour, and this will usually go here. We will see that in a moment. And then for main batteries on this one, I use the HRV 4200 milliamp hour 60C. I wouldn't say these are really great packs, but they probably do not need to be, because being an 8S setup, they do not require, or they do not demand as much current, let's say, as a 6S setup. And these are pretty light. They come, the 2-4 cell pack, they come at around 800 grams. So this allows me to keep my weight in check. And let's put this in here so you can see that I have different velcros for different airplanes. For example, I use the same ones on my Gripen, and on the Gripen they have to go like this, but here they must be flat. So I'm using these small velcros, and let's just put it in, and I just shovel these all the way back, and then make sure they are properly secured. I mean, already with the Velcro strap, they are not going to shift forward or backwards. And then with this, I make sure that this is not going anywhere. You see, this is solid. And then I would take this one and just put it right here. And no, for this one I do not use any other sort of additional strap, but I have these do not weigh a lot, and I have been flying all my jets with this sort of attachment for receiver packs, and never ever have I had one of these packs just try to eject itself. So I think it's just fine. And then also, as soon as I put everything in, I tuck the wires away. I will usually connect the ground, and right now I'm not going to power the EDF, so this will stay like that. And here the same. So this is already prepared to connect and start up. And okay, so let's turn the transmitter on.
Welcome to OpenTx. Switch warning.
Okay, all switches should be
Signal low.
up. There we go.
Roll rates. Flaps up.
And now that everything is set, I will start the jet. So let's just plug it in. Oh, I also forgot there is a gyro, a Hobby Eagle A3S3 underneath the wooden tray. And there we go. Now we have to wait until, there you go, when the ailerons do that flick, that flicker, that means that the gyro has set up correctly. The first thing I do is to turn the gyro on and see that the stabilizers do not move.
Gyro rate low.
Okay, this is correct. You should always do this, because the gyro will not always initiate correctly. And maybe when you turn off, when you turn on the gyro, this will deflect to an offset. And if that happens, you should not fly the plane. You should plug everything off and plug it on again and do the recalibration. This happens, as a matter of fact, this happens very often with this gyro, so you are warned. Add this to your checklist if you haven't already. And now let's deploy the landing gear to make this easier. Oh, by the way, you can now see the LED inside the cockpit. It's a subtle touch, and also here you have the pilot light for the gyro, so you can quickly check
Gyro rate mode. Gyro heading home.
the different
Off.
modes of the gyro. So let's close this for now. And
Gate down.
there we we go. So give me a second because I'm going to put the plane on the ground. It will be easier for me to do the explanations. Hang on there. So, first and foremost, now the gyro is off, and let me see if I can, will be better if I can, there it is, so you can see the transmitter at the same time as the plane. So here I have the dual rates, so this would be low rates, and then middle rates,
high rates,
and high rates, and same thing in the other direction.
middle rates, low rates, middle rates, high rates.
You see that between middle and
Low
high,
rates.
there's not much of a change. I essentially fly 100% of the time at full rates,
High
so
rates.
let's leave it like that for the moment. This is the landing gear, and these are the flaps. And
Flaps 1,
for the first flap position, notice that
Flaps
only the
Flaps
center part
1.
deploys, and then
flaps
for
2,
flaps 2, the center part deploys a little farther down, and then you have the outer ailerons drooping just a little bit, which is more or less what the full-scale
Flaps
Raptors
1.
do.
flaps up,
Then this here is the timer. You can see timer running, and I have the alarm set for 4 minutes. Now we'll get into the fun part. So for starters, you can see that my rudder now just moves the rudders. My pitch input only moves the staffs, and my roll input moves both the staffs and the... I will call this, to make this easier, I will call the outer wings control surfaces ailerons or elevons, and the inner ones, I will call them flaps, so to speak. So here I'm moving the ailerons and the tailerons. But now, if I switch this one here,
reflex,
now the ailerons also deflect up and pitch down in accordance with the tailerons. So now they are working as elevons. Before this, they were just operating as ailerons. And after pitching up, they are also operating as pitch control. And then I have
mixed with flaperons,
this second mode in which also the inner flaps will turn and operate as a pitching device. And you can see, for example, if I hold this and go back,
reflex,
here
elevator
you
mixed
can
with
see
flaperons,
very easily how this is working.
elevator mixed with flaperons,
So in normal position, only the elevators work.
reflex,
Then in the first position, the outer ailerons will work as a pitch device.
elevator mixed with
And full
flaperons,
up, the flaps will also work in pitch. And to make it a little bit more interesting, when I have this switch here, I can use this slider to control the reflex of the wings trailing edge. So I don't play with this often. You see that I cannot pitch down. I made a custom curve to set this up so that I could not put it the other way around. But in case I want to experiment with high alpha things, I have this option of regulating the reflex. But as soon, if anything is not working, of course you can just put this up and everything will be fine. But you can just disable this, and in the normal mode it will not act.
reflex,
So now we leave it as it was before. And we move on to the next switch, which is this one right here. And
Flaps synced with ailerons.
you can notice now that the flaps are also operating with roll. You see, this would be the normal mode. And
Flaps synced with ailerons.
this is with the flaps mixed in roll. Notice as well that everything that my switches are doing, the radio is telling me, because when you are doing so many different things, sometimes it can be hard to remember. So you better have the radio be prepared to tell you everything. It makes it easier to not mess things up.
Camber.
And this camber thing, you can see here that this is essentially a combat flap application. You can see that when I am pitching up, the flaps are pitching down. This serves the purpose of making tighter turns when you are flying rather slow. You can see the F-18s do this a lot in air shows. So this is the opposite to, let's say,
Reflex.
this,
Elevator mixed
where,
with flap roll.
where the flaps are going along. And
Camber.
of course, you can have the combinations of the two. So you can make really weird stuff here. But I do not use this a lot. As a matter of fact, I have tested it a couple of times, and that's pretty much it. That's not how I fly the plane. But since I'm explaining everything, I might as well tell you. And then on here, I have the gyro, and this is the gain for the gyro. So if I can turn the gyro gain up and down here. Full up is gyro off. Then the first position
Gyro rate
is
mode.
3D mode direct rate.
Gyro heading home.
And the third position is, it is also direct rate, but there are some axes that will be working in heading hold. And this is also for experimenting. I usually fly in direct rate, not in heading hold. I do not recommend using heading hold on aircraft. But I think I have something like heading hold on pitch and yaw or something like that. I would have to check it.
Off.
The final thing here is
Pro on.
the spring-enabled switch that, as you can
Pro
see,
on.
as I'm activating it, nothing happens. But then, if I am adding rudder or yaw rudder to left or right, you can see that the corresponding wings control surfaces will open differentially to help assist in yaw control by adding drag to the left or the right wing. So for example, here I want to yaw to the left, and I'm opening the control surfaces so that the aileron deploys pitch down and the flap deploys pitch up. You can do this also in the opposite way. So the aileron could be going pitch up and the flap could be going pitch down. I have done both, and I mean, it's something that I'm just experimenting with. It has its uses, for example, when you are doing hammerheads at very low speeds. But when you do this, what will often happen is that the plane will flip. So I should probably add a little bit of aileron compensation in there. For example,
Pro on.
when I'm doing like this, there should be a wee bit of aileron deflected in order for the plane not to flip. But I haven't done that yet. So this pretty much covers. Well, then let's pause here for a second while I replace the battery of my GoPro, which has died on my face. Okay, yeah, so now you have been able to see everything that I have programmed into the aircraft in terms of mixes, but now I will tell you how I'm flying this airplane. So essentially, I'm going to have the full rates all the time. Then I will be having
Gyro rate
the
mode.
gyro turned on, and I will have the ailerons be used as elevons. So this is what it looks like. So the flaps are only used as flaps for the most part, and this is how I'm flying 99% of the time. I guess we can now turn the plane off and we will head to the transmitter menu and check that out. I hope this works good enough. Okay, so let's head into the menu and let's skip the model selection page. On this page, I think the only couple of things that are worth noting are here that I have the 16 channels being fed through to the receiver, and here I have the trim step is set as medium. I don't like it being fine because, if the steps are too small, it's hard to control the aircraft in case of an emergency. If you need to retrim on the go and the trims are moving so very little, the control surfaces, it's not great. So I usually have it in medium. And then I have extended limits for the control surfaces and extended trims enabled as well for pretty much, well, extended limits of course are to get the most throws and aerobatic capability of the aircraft. And the extended trims are for that safety reason, in case I need to have a lot of deflection, because maybe, sometimes weird stuff happens. You can lose the linkage of an aileron and it can wreak havoc on your airplane. So nothing to see on this menu. And here in flight modes, not much to see here. I have only 3 flight modes. The first would be flaps up, so that would be for normal flying. And then we have the flaps 1,
flaps 2,
and flaps 2. And you can see here in the assignments that all the trims are shared between the flight modes, with the exception of the trim for the pitch axis, that they are separate between flight modes 0, 1 and 2. That is, my trims, when in flight, they are all shared in all the flight modes, with the exception of the pitch trim, which will have a separate stored value for flaps up, flaps 1 and flaps 2. This helps make pitch compensation with flaps much easier. So it's not programmed as a mix, but rather baked here in the flight modes. And now we move on to the inputs page, and this is very important. Let's spend some time here. You can first see that I have aileron, elevator, throttle, and rudder inputs, and the first 3 are, let's say, unmixed. And then we have a few others that are LAT and roll T. And why is that? So let's say that some of the channels are controlled directly from the receiver, and some of the channels go through the gyro. So I have different inputs to feed to the gyro and to the wing control surfaces, for example. So essentially what this allows me to is that I can switch between high, medium and low rates, and this is only going to be affecting some input but not the others, and this comes handy later on when you are setting up the aircraft. So here you can see my dual rates and exponential for this plane. So for rudder we have 75, 85, 100 in terms of weight, and no Expo to 30% Expo in the case of the medium and high rates. Then for elevator I have 60% weight at low rates and then 100 in both medium and high. And the exponential shifts from 50 to 80 to 70. And then for roll, I have a weight of 50, then 90, then 100 and exponential goes from 65 to 75 to 80. But again, remember that then I have these other inputs that are unmixed. And it is very important that you solve, at least if you are working with OpenTx, you should solve all your dual rate and expos in the inputs page, because if you do this in the mixing page, you may run into some problems with offsets when switching between different mixings or rates or whatever. So finally we get to the mixes page, and the first thing you'll notice is that the channel assignment is nothing like the traditional, let's say, Futaba or JR, where you have channel 1 is aileron, channel 2 is elevator. On my EDF jets, instead, what I usually do is I will assign the channels depending on where the receiver is set on the airplane and where the wires are coming from, to optimize everything and try to keep the wiring as tidy as possible, and to use as less wires as possible as well to save weight. So channel 1 is the EDF, and there's nothing to see here. I mean, I'm just taking the throttle as my input, and the weight is 100%, and that's that. Then the second is the landing gear, and you will wonder, well, why is the landing gear here? Well, it comes handy because I have the landing gear and the wheel steering right next to each other, and this allows me to very quickly access the offset trim for the wheel separately from the rudders. So I can, if any time that I am doing some repair work and the wheel is needs to be aligned again, it's very easy for me to just come to this menu, and the first thing that shows up is the wheel. And you can notice that I have two different settings for the wheel. One has the 100% weight. This would be with the gear down, of course. But then when the gear is up, I only have a 15% weight. So this means that it will still move a little bit, but just a little bit. And I do this because I have found on previous jets, it would often happen that when I raised the landing gear, oftentimes the steering servo may get stuck. And by allowing a little bit, if you are allowing a lot of movement on the steering when the gear is up, chances are that you are going to cause binding. But if you do not allow any sort of movement and the servo gets a binding situation, then you are going to have a big problem, because the servo is going to be under constant stress and it will probably fry. And by allowing it to move just a little bit, it will most of the time just be enough to unblock the servo in case there was any binding. Or well, at least this is how I do it. You feel free to disagree or do things your way, but this is what I have found works good for me. And you can also do all the sequencing here. And then channel 4 is the left aileron, and you can see how I'm writing this here. So for the outer control surfaces of the wings are ailerons, and the inner control surfaces are called flaps. And the L is for left, obviously. And then you have all the same with aileron right and flap right. And you see there's a lot of mixes going on here to enable everything that I showed earlier. So let's see that. So the first mix is normal roll. And also remember that when you are working on OpenTx or similar softwares, the lines that go on top are the ones that have preference. So the most important control should be the top line. So of course, for ailerons, the top line is roll. And then there's a second roll line, which is, actually I didn't talk about this earlier, but this is a differential. And so I can use the ailerons deflecting in the same amount up and down, or I can turn on differential. The differential here would be in the position where the flaps are acting as elevators. I'm also enabling the roll differential on ailerons. Ideally, I would have this on a separate switch, but literally I run out of switches for this aircraft, so that's out of the question. And then we have, this is the, also, sorry, notice that the first two lines are a replace function, so it's either or. It's either working on the first or the second line. Whatever I do with the switches, you can see that either this one or this one is active, because this is what is commanding the roll on these control surfaces. Then everything else is an add function, so it will be adding or subtracting on top of the roll mix. So the first one is the elevator, and remember now that we saw that I had two different types of inputs, one that had all the mixing for dual rates and Expo, and one that didn't. So here, these are the inputs that I created with the dual rates baked in, so to speak, because all the wing control surfaces are not routed through the gyro, so they have to be mixed here, so to speak. And then what else? When I'm turning on the ailerons as elevons, this mix turns on. And I do not have it on a switch position because it's taking 2 of the 3 positions of a 3-way switch. So instead of, let's say that I made a logical switch that is active when, say, this is switch E. When switch E is on the top and middle positions, then this switch is active and this turns on this mix. So then we have the, this is the rudder to aileron mix, and this is for the crow, for the differential crow thing that I explained, where I am using the wing control surfaces to generate drag in order to assist yaw. So what I'm doing is, for example, I will apply rudder, and then the ailerons will be moving in order to generate drag in conjunction with the flaps of either the left or the right wing. So this goes here, and it's using a custom curve. And why is that? Because of course, when you are doing, for example, rudder to the right, you want only the control surfaces of the right wing to deflect. And when you are doing rudder to the left, you only want the control surfaces of the left wing to deflect. So what I essentially did is to, we will see this custom curves later, but I flattened out the part where, so for example, when I'm doing this here, to the right, the left wing is not working, and when I'm doing this to the left, the right wing is not working. This is easier seen on the curves page, we will see that later. Then this is the flaps, and this is only, since these are the ailerons, they are only deflecting in the flaps 2 position, so there's only one flap line here, which corresponds to flight mode 2. So here, instead of a switch enabling the flap, it's a flight mode that is triggering this mix to go on. So
Flaps 1.
you can see it there. So for example, when I'm
Flaps 1.
in flaps 1, it's not turning on,
Flaps 2.
and then in flaps 2, it's coming in. And you see that it's only a 25% deflection.
Flaps up.
And then this is the left slider, which also uses a custom curve. This is what I use to make the trailing edge of the wing reflex up with the slider. But I'm using this custom switch in order to make sure that half of the throw is not actually moving anything, because I only want this to work in the up direction. I mean in the pitch up direction, not in the pitch down. So same trick I used as for the differential crow. And then we move to the left flap. And here on the left flap, let me move down. Here are even more mixes than before. First we have the roll, which as a matter of fact, it is turned off most of the time. It will only turn on, sorry, here.
Flaps synced with ailerons.
Flaps synced with ailerons. There it is. And when I hit that switch on, the flaps will act in roll. Otherwise, they will just be left centered. Then there's the elevator mix to the flaps. Same, so they would be acting as elevons or flap elevons if you want. I don't know what to call them now. As a matter of fact, a full-scale Raptor pilot explained that they no longer say this is an aileron or this is an elevator. Like each control surface is just some sort of actuator, so to speak, because now everything is so smart and flight computer control that all the flight controls are working to control all the axes of the plane at the same time. It is no longer that rudder controls yaw, the elevators control pitch and ailerons control roll, but rather everything is moving at the same time in interesting ways to try and make the plane do what the pilot wants it to. So sorry for that digression, but let's get back. You can see here that there are a couple of mixes that mix elevator with flap. This is because one of them will make the flap work as an elevon, and the other is the combat flaps that I showed you earlier, that were or flap assist I call it, when the flap will actually pitch down when you are pitching up, just to increase the lift of the wing a little bit. And you can actually see that the weights of each are in reverse. So the elevon function is 70 plus 70, and the flap assist is minus 50. Then there's again the mix for the differential crow for assisting hammerheads and things like that. Or even maybe when you are in high alpha, they might give you a little bit of extra control. And then, since these are the flaps, here are the flight mode 1 and flight mode 2 with a 60 and 80% deflection weight. And finally, the slider for the permanent reflexing that I explained earlier. And then channels 6 and 7 are the exact same thing, but for the right aileron and right flap. So we can skip this now. And finally we come to channel 8. Here's the gear door. So usually this would have been right next to the landing gear to make sequencing easier, but for some reason it ended up here, probably because of the wires were coming from different places. And it made things easier in terms of hardware on the plane. Again, since I'm using three-way switches, you can see that one position is a physical switch for the input, but the other is a logical switch. For example, in this case, switch up means gear up, and switch center or switch down is gear down, something like that. Then channel 9, channel 10, and channel 11. These are, sorry, actually from channels 9 to 13. These are the channels that are fed to the gyro, which controls the rudders and the stabilators or ailerons. And these are separate from everything else. Gyros often do not like trims and things that are off-center, so be careful when you are setting up a gyro and that everything is very well centered. And in any case, the settings for the tail control is rather set up on the gyro, not on the transmitter. So here it's just a roll feed, a couple of elevator feeds and the rudder feed, and then there's the mode switch and the gain up. So it's 5 channels in total. And let me see, why did I have a couple of pitch feeds to the gyro? I don't recall.
Reflex, elevator mixed with flaperon.
Oh, sorry. Yes, I do. It took me a while. I just remember what this is. You're going to laugh at this. This is a weird thing as well. This is an inverted differential for the stabs. You may be used already to differential on the ailerons, but remember that these ailerons are working in pitch and roll, and setting up a differential was not so straightforward because it's going through a gyro. And the way I did that was to add a special line that will add to the pitch mix when I am rolling. So how do I explain this? For example, when the plane is flying normal, you see that this mix is inactive. So the gyro is controlling the elevator only through the elevator. So this is the only thing that is feeding the gyro any information about pitch control. But then, if I switch this on,
Reflex,
now this would be on. Whenever I am rolling the aircraft, because see that this is a roll to elevator mix, whenever I am rolling, the ailerons will also deflect in pitch. And you would say that makes no sense because you don't want to pitch when you are rolling. But the thing here, the trick is that I'm using a differential curve, which we will see now. Which goes negative on half of its. Let's see if I can show you here. Okay, now you can see that I have a custom curve set up, but we have to go to the curves to see this. Never mind. The thing is that when I am commanding roll either to the left or to the right, the ailerons will pitch a little bit down. So contrary to how the differential would work on the ailerons, where you would want the aileron going up to go slightly more up than the aileron going down. So this is one funny trick that I also came up with to experiment with aileron differential when using a gyro. And this sums up everything that I have said for the F-22 as far as mixes go. And it all comes to 13 channels, and I still have 3 free channels that I will probably use for my FPV conversion of this airplane eventually. Then moving on to the outputs page, again you can see that I have everything labeled, which comes very handy. And you can see that all the subtrims are set at 0, pretty much. Yeah, I think it's good practice to have everything mechanically set up if you can. And then you can see that the endpoints to the left and the right are different for some channels. So the way I approach this is the first time I'm setting up the airplane, I will go through this menu and try to deflect all surfaces to left and right and see how they are deflecting and measure things up. And first and foremost, I will try to get the maximum throw out of the servo. So if I can increase the, for example here, the wheel is maxed to 110 to left and right. If this allows the servo to move farther, then I will use it. If it does not, for example, some servos will already reach their limit at 100, there's no point in, as a matter of fact, it would be detrimental to make the sticks go farther than 100, because then you would have, for example, from here to here, the servo would move, but then this space here, the servo would do nothing. So it's good practice to just go through all of the servos and check everything individually. Just set everything up so that you make the most out of all the servos. And once you have done that, you also may want to check that things are deflecting symmetrically. So for example, for the elevators, you don't want one stabulator to go higher than the other when pitching up or down. And same thing for rolling and differential. So here, for example, you see things that are not equal, and then of course this is ailerons, flaps. So you need to, if you want to set everything the best you can, you need to spend some time on this sort of thing. And then these channels that go into the gyro are set up with a higher range. For example, for the mode channel, this allows me to have more resolution with the knob when I am setting up the gain. And my GoPro camera died again, but I think I'm going to let it be dead for a while. It's not doing much as of now. Then next up is here's the curves page, and you can see the wing yaw curve 1 and wing yaw curve 2 and the differential. So let's start with the last one. This is the, as I was explaining, what I use. So a normal curve, a linear curve, would be just something that goes from here to here, right? But by reflexing this side of the curve on a 3-point curve, for example, you can make that, imagine that this is roll and this is pitch, for example. So if you are controlling the pitch channel, when you're rolling to the right, the ailerons will deflect in one direction, and when you're rolling to the left, the ailerons will also deflect in pitch in the same direction. So they will not be acting differently whether you roll to left or right. This is what I am using to have the ailerons operate differentially when using a gyro, if that makes sense. It may sound a little bit confusing at first, but I'm sure you will get it very quickly if you just give it a few minutes to think about it. And then the other two curves these are 5-point curves, and these are for the differential crow. And here what I'm doing essentially, you can see I have one of each. I'm making the output completely dead to one side of the stick. In this case, the left side wouldn't do anything, and in this case, the right side of the roll stick wouldn't do anything. And on the other, close to the center, it's barely going to do anything. And then this is sort of a fake Expo, so to speak. And when you are reaching the travel limit, then you will have the control surfaces open all of a sudden. So this allows you to have the mix turned on, and you will barely notice anything on most of your normal flight, which happens around the center. But then when you reach the end of the stick positions, then you will have that butterfly opening effect. So that's all I have for custom curves. We can skip global variables, as I'm not using it either. I'm not going to go now through the logical switches that I have set up, but I mean, this is pretty much completely dependent on how you want to set up your own switches. And for special functions, this is essentially all the voice tracks that play when I am moving switches, things like that. Also SD logs, and that's pretty much it. No Lua scripts, and that's it. We have reached the end. And the only thing here that may be worth going through before quitting is this page, the outputs page. This comes very handy to see that everything is working correctly. So for example, now with all switches up, but with high rates enabled, you can see that when I am acting on pitch, the only channel that is doing anything is the channel that is feeding the pitch signal to the gyro, and everything else is not working. Then if I activate the ailerons, now the left aileron and the right aileron are also working. Then if I activate the flaps for the pitching function, then you have the left aileron and flap and the right aileron and flap, all of them working in conjunction with pitch. I'm deactivating this now, and the other thing that worked with pitch was the combat flaps.
Gyro rate mode.
Sorry,
off.
not this one.
Flaps synced with ailerons. Camber.
Camber, this one. I use the camber audio because essentially you are giving more camber to the wing by slightly deploying flaps, so that makes sense for me. And now you can see that the flaps are also working in conjunction, or rather in opposition to pitch. And another interesting thing is when now if I turn the slider, you can see that I can offset the position of the entire wing trailing edge here. And in this position, I also have active the differential aileron, so to speak. So it's hard to see, but if you see here, I'm moving the roll command, and of course you see roll moving, but look carefully right below it, you have the pitch input for the gyro, and you can see that there's this minus 9.3 to minus 9.2. This is, and it doesn't matter if I'm rolling left or right. Sorry. This is always a minus. You see what I mean? This is adding a little bit of pitch down when I'm rolling either to the left or to the right. But most of the times it is off. You see that now it's not doing anything. So different ways to mix things. What else? Let me see.
Flaps synced with ailerons.
Now, yeah, sorry. I have been talking about pitch. Now we will see roll. For roll by default, you have the roll being fed to the gyro, and you have the ailerons. The ailerons are always on. And
reflex.
This one, but
flaps synced with
here.
ailerons.
Now it's not just the ailerons, but also the flaps.
Reflex.
You can see that here it's only the ailerons moving, and then
camber. Flaps synced with ailerons.
you have everything going at once.
Camber.
And we saw that already. Then we have the gyro, of course, and this here is the switch.
Gyro heading home.
And you can see that
gyro rate mode.
The mode gain
gyro
goes from minus 100 to 0 to 100, or rather 130.
Gyro rate mode off.
And right underneath it is the gain, so it was maxed out. I pretty much fly with full gain on the Raptor all of the time, but you can see this knob here. This type of screens really come handy to see that everything is working as intended when you are doing the setup of your airplane. And then there's the flaps.
Flaps 1.
You see that with flaps 1, you only have the flaps moving left and right, and there's a slight
Flaps
correction
up.
with the pitch, even though it's going through the gyro.
Flaps 1.
You can see there that it's going from 1 or 0.9
Flaps
to
up.
0.1. So on normal flight it will be close to 0, but of course you still need to
Flaps 1.
do something about it when you turn the
Gyro
gyro
rate mode off.
on. And then when you turn flaps 2, you will see that the flaps will move a little bit farther and the ailerons will drop a little bit.
Flaps 2.
There you go.
Flaps
So this
1.
is going from
Flaps
flaps 1
2.
to flaps 2. And there's also a little bit of a slowdown of the function.
Flaps 1. Flaps up.
And now for the differential crow thing. So this is the rudder, which you can see. This is the rudders are controlled by the gyro. So this is the main control here. And the wheel is only moving a little bit now because it's in the gear up position. But if I
Gear down.
deploy the gear down, you can see now that the wheel moves completely. And
Gear up.
gear up. Also, I didn't explain this earlier, but I added some exponential to the wheel on the mixing page because I didn't want to make a separate input just for it. And I wanted it to be controlled slightly more smoothly than the rudders. And then
Crow on.
when I activate differential crow, you can see that now only the right wing, for example, here I am, this is right, yaw to the right. You see that the left wing is not doing anything. Only the right wing is deploying differentially the aileron and the flap. And to the opposite end, we have the exact opposite. Now the right wing is not doing anything and the left wing is moving. And then you can also see that near the center, essentially you have nothing happening, so you can still have a normal flight, and then as you exceed the 50% of the control stick through, then it starts acting. And when it's off, it's off. So this is not a full flight control system like you would see on an F-22 Raptor, of course, but it makes, besides being a funny experience, it makes this thing behave a little closer to the full-scale one in some regards. So I think we're done. Yeah, I think we're done. I don't think we left anything behind. If you have any doubts, which I am sure that you will, just hit me up on the comment section and I will try to help you out with what I can. And that's it for me for now. Thanks for tuning in and have a nice one.